In problem number 30, we're looking for the equation of the line tangent to a radical function. And that function is square root of x minus 1, and we want to find the equation of the tangent line when x is equal to 5. To find the equation of any line, the first thing we need is a slope, and that slope in this case is the derivative of the function when x is equal to 5. We're going to find that derivative using the limit process. So we have the limit as delta x approaches 0 of f of 5 plus delta x minus f of 5 and all over delta x. And we begin to plug in here. So we have the limit as delta x approaches 0, and wherever we see x in the original function square root of x minus 1, we're going to replace that x with 5 plus delta x. So f of 5 plus delta x is now square root of 5 plus delta x minus 1. Now for f of 5, all that is the value of the function when x is equal to 5, and we know that that's 2. And we put this all over delta x. Since we have a simple fraction with a radical expression in the numerator, we're going to be able to use the rationalization process to evaluate this limit. And to do that, we want to multiply the numerator and denominator by the conjugate of the radical expression in the numerator. And that is 5 plus delta x minus 1. Then plus, and that's the only difference with the conjugate expression, instead of square root of 5 plus delta x minus 1 minus 2, we're going to have square root of 5 plus delta x minus 1 plus 2. We don't change the sign, the minus sign, inside the radical. And we're going to multiply top and bottom by the same thing. Now, since we have 5 plus delta x minus 1, we really should be able to go ahead and simplify the 5 and the minus 1 to be 4. So under the radical, it would just be 4 plus delta x. And that might be a little bit easier to work with. So we have the limit as delta x approaches 0 of square root of 4 plus delta x minus 2 over delta x, and we're going to multiply the top and bottom by square root of 4 plus delta x plus 2. Alright, now we multiply it out. This is a difference of two squares. It's just first term squared minus second term squared. But you have to remember to square the second term. So the first term squared would be square root is just 4 plus delta x. The second term squared, which is the 2, is going to become minus 4. And you can see how the 4 and the negative 4 will zero out, leaving only a delta x in the numerator. And the denominator becomes delta x, which was originally there, times the quantity square root of 4 plus delta x plus 2. The plus 2 is not under the radical there. And we don't want to multiply this out. From this point you can see that the delta x's will cancel, leaving only a 1 in the numerator and a square root of 4 plus delta x plus 2 in the denominator. When we set delta x to 0 now, we're going to get 1 over square root of 4, which is 2, plus 2, or 1 over 4. And that is the slope of the tangent line that we're looking for. So now we go to finding the equation of the tangent line. Finding an equation of a tangent line requires two things, a slope and a point. We have our slope, that's 1/4. We have the point, that's 5, 2. And we're ready to use the point-slope form of a linear equation. That is y minus y1 equals m times x minus x1. y1 is 2, and so we have y minus 2 is equal to m, and m is 1/4. x1 is 5, and so we have the equation y minus 2 is equal to 1/4 times the quantity x minus 5. And I just simplify that out because I want to show the solution on the graphing calculator. We have y equals 1/4 x plus 3/4. And so I put in the function square root of x minus 1, zoom standard, and that's the graph. And I went to second program and then tangent, plugged in 5, and it gives me the equation I'm looking for.